Good evening. Welcome to the BIGG Climate webinar. We'd like to welcome Mr. Dale Gray, our guest this evening, guest presenter. My name's Jane Evans. I'll be your facilitator for the evening. I would just like, before we start, just to acknowledge that this webinar is supported by the Murraylands and Riverland Landscape Board through funding from the Australian Government's National Land Care Program and the Landscape Levies. So the Barossa Improved Grazing Group, I'll just give a quick background before we start. The BIGG Group was created in 2012 and became an incorporated body in 2019. We have conducted over 27 rural projects in collaboration with numerous industry partners, agribusinesses, advisors, state and national stakeholders, and won several industry awards, holding a strong commitment to communication regarding project learnings and industry information. So our presenter, Mr. Dale Gray, this evening, we'll look at major climate influences unfolding for 2023 and interpreting seasonal climatic models and weather analysis for primary producers in the Barossa region. Dale Gray is a seasonal risk agronomist with Agricultural Victoria, where he's worked for 28 years. His roles have included crop and livestock and pasture research and extension in both dryland and irrigated environments, including a stint as a soybean variety selector. Dale provides agronomy, climate change, weather analysis, and information for farmers, agribusinesses, government, and the media across Southeast Australia. He's been interpreting seasonal climate models from around the world every month since 2008. Dale is the author of the Fast Break climate newsletters for Victoria, South Australia, Tasmania and Southern New South Wales, and produces a monthly YouTube climate update called The Very Fast Break for Victoria, South Australia and New South Wales. In 2022, he was a recipient of the Grains Research and Development Corporation's Seed of Light Award for Excellence in the Grains Industry Communication. I'd like to offer a very warm welcome to our guest, Mr. Dale Gray.
Thank you very much, Jane. Let's hope I can live up to that introduction. And good evening from Jara country here, the ancestral homelands of the Jar Jar Wurrung people here in North Central Victoria, and particularly at Bendigo. So my first slide is, first of all, we're going to look here at just an image a couple of days ago, mainly from satellite data, but showing the absolute temperature of the surface of the ocean around the world. We can see that's anywhere from 0 frozen through to, well, roughly about 30, 31 degrees perhaps. And the center of the equator, along the equator, is the warmest part of the ocean. That's because that area of the ocean is closest to the sun. It's the sun that's driving that extra warmth along the equator. And obviously, as the world tilts during our winter season, it's a warmer ocean north of the equator, and in our summer season that comes south, and we're sort of halfway there at the moment of getting the warmer water sort of further south of the equator. The reason ocean temperature is so critical is because there's no meaningful evaporation off the ocean unless the ocean is at least over 24 degrees. So we can see here, perhaps off the coast of Nelson and Kingston down there, the ocean's a little over sort of 13 or 14 degrees. Be pretty chilly. You need a wetsuit this time of the year for sure. And there's just no evaporation going on down here whatsoever. But once we sort of get roughly north of the tropics of Capricorn, well, the ocean rapidly warms up. And when we're to the north of Australia there, we can see a large blob there that's roughly around 30 degrees at the moment. And because the Earth is still tilting into summer, the absolute temperature of the ocean will continue to get warmer up in this area as we get right through, reaching a peak normally somewhere around March. What's also interesting is just how very small differences in temperature make very big differences in evaporation of the ocean. So this is the world's engine room for rainfall. This is where the moisture in the atmosphere is. And just about every drop of rainfall that's ever fallen at your location has evaporated off the ocean somewhere, and generally to our north. And quite surprisingly, this coral sea region up here, sort of from Brisbane up to the Solomon Islands, is a real critical zone for moisture evaporation in Australia. And that may seem quite counterintuitive when you see the weather patterns coming from the west and moisture sometimes being dragged from the northwest. But that's usually the cloud, and the cloud only shows you where the atmosphere has got the right conditions to physically show up and condense in the atmosphere. It doesn't actually show you where the moisture is evaporating from originally. So this area over here is really quite critical as a moisture source for quite a lot of places in southeastern Australia. This is a different map. This one's showing how much water is in the actual atmosphere, and it's from the ground level quite up to the stratosphere almost, up a long way, up where the planes fly, the jumbo jets. And you can see this fluorescent green color is where it's saturating out at the maximum amount of water that air can hold. And you can see that, I hope, that those really warm areas north of Australia are a key feature around the world of being one of the major areas at the moment that's pumping out the largest amount of moisture. There's a bit around here, there's a fair bit over parts of South America at the moment too, but that moisture is not necessarily coming off the landmass, it's still coming off the ocean somewhere here. We can actually see some of the warmest part of the ocean there is still north of the equator. It's still got a little time to move down there, but the moist, dense air up there and the warming, rising air is up in the tropics, and it's where that warmest ocean is that occurs. You can see there's, you know, the air down here is really quite dry and cold and dense and heavy for that matter, south of the tropics. This is a different map, but the same data as the first one I chose. The first one was the absolute ocean temperature. This one's a sea surface temperature anomaly chart, and so it's showing the areas of the world where the water is 2 degrees warmer in the oranges or 2 degrees cooler in the cold. And I mean, what's interesting is that the scale of this only goes to ±5. So world ocean temperature compared to normal doesn't change that much. It's often just sitting there in the grey colours being completely normal. But when we get cooler than normal water along the equator in the Pacific Ocean, particularly in the middle of the Pacific Ocean, we have what's called the La Nina phenomena when it's colder, particularly when the water there is sort of 1 to 2 degrees cooler than normal. The other area we look at for phenomena is in the Indian Ocean, and we look for a phenomena called the Indian Ocean dipole, and that's where we're comparing the differences between this west box off Kenya and this east box off Sumatra in Indonesia. And at the moment, you can see that those two boxes are all just sort of slightly warm. Now, this year we had a negative Indian Ocean dipole. We had very much warmer water in this area, and we had neutral to cooler water over here off Africa. And that was essentially driving a La Nina-like pattern in the Indian Ocean. Now, this La Nina here is actually pretty weak at the moment. It's 0.62 degrees cooler than normal. The threshold we usually say is around negative 0.8. So it's not quite at that, but this event has never really got to that kind of threshold. But the Americans have a threshold of negative 0.5, a lower threshold than Australia. So yes, it's a weak La Nina. But what's been interesting is that despite out here being a fairly sort of poxy kind of temperature in terms of classic La Ninas, what we can see in terms of this big horseshoe of warmer water is just a classic fingerprint of a very strong La Nina. And in fact, the ocean temperatures in this area I've marked here up in the Coral Sea have been the warmest on record since about July of this year. In October, they were warmest on record as well. So if you just go back to the slide before where we're talking about evaporation and temperature, small differences in temperature of the ocean to the north of us make very big differences to the evaporation, because evaporation and the temperature of the ocean is not a straight line relationship. If you remember your scary year 9 and 10 maths, it's not a one-for-one thing. It's actually more exponential, so that when you make small changes in temperature with something that's already quite warm, the amount of evaporation goes up really a long way. So changes of 1 to 2 degrees in the ocean temperature up here of an ocean that's normally warm anyway makes massive differences to either killing off the evaporation or really accentuating it. So this is just a graph of that Nino 3.4 region. The scientists take that whole box and work out the temperature. And here's that ±8 sort of threshold here in the blue lines. And here's where we've been going of late. We've sort of, we almost got to negative 0.8 there in August, but then we've sort of struggled to get really much below that. And we've been, just at this, what's called a, very weak La Nina. And then 2022, late 2022, really over late spring, summer, we had a very similar type weak La Nina event. And then in spring of 2020, we had a much stronger event in terms of the actual temperatures of the Central Pacific. If you look back in 2019, that's 2018 there, it could be 2018, I think 2019 as well, we also had some weakish El Nino-like conditions, which was the last time we had one of those. But we've been in this state here since about August of this year, where the temperature of the ocean has been cool in the middle of the Pacific. We look at the Indian Ocean dipole values. That's an index called the Dipole Mode Index. It bounces around as well, and its threshold is negative plus or minus negative 0.4, which is these blue lines. And you can see that since July of this year, we've been in negative Indian Ocean dipole conditions here. And we had very weak negative IOD conditions also last year in 2021. But you can see that we had a really strong IOD positive in the spring of 2019, and one also there in 2018, which just kind of matched up a bit with the El Ninos. So this particular phenomena here has fallen away. It's as it would normally do at this time of the year. Once the monsoon, the northern wet season kicks on up there in the northern parts, it really disturbs the Indian Ocean very rapidly, as opposed to the Pacific Ocean. And the Indian Ocean destabilizes normally in November. And so whatever's been going on reverts back to normality. So we did have a negative IOD, and you can see there that very rapidly, once the winds started to change direction up for the northern monsoon, that the temperatures there around Sumatra and off Africa have just completely collapsed. And then the whole thing kind of starts its decay. We'll talk about the La Nina soon, though, in terms of what it's up to. So there's two phenomena we've had this year, a La Nina and a negative IOD. They often work together, and they're both rain-bearing systems, I suppose, one in the Pacific and one in the Indian Ocean. This is just a map of the, from memory, this is at Roseworthy, the closest place I could get off our website to you. It will be almost no different in terms of the absolute. The rainfall might be different, but the sort of things that we're talking about in terms of climate effects will be exactly the same, I can guarantee. We're looking at the April to October growing season rainfall here, and we've just really ranked it from the lowest year up to the highest, and we've color-coded it for the different climate drivers. So if we're looking at these, the darker blue, which is the La Nina negative IOD similar to this year, well, we can see they're all kind of towards the halfway to the wetter end. And this year, we're probably going to see that jumping up to maybe wettest on record in some parts. We look at just the negative IODs, they're in the green. Well, they're kind of all sort of skewed this way. A fair few of the El Ninos and the positive IODs are down here in the drier end. But it just goes to show, though, that none of these climate phenomena are all or nothing things. They don't have a 100% guarantee when they form, because we can see here's some drier end of things that have actually been quite wet. In fact, the wettest growing season on record there at Roseworthy was in fact a positive IOD, which is incredibly unusual, but nonetheless sort of weirdly possible sometimes. If we look at just the what would we call, Peter Heyman there would call the chocolate wheels, these tercile distributions of the rainfall into the wetter in blue and the average in yellow and the drier in red, we can see that historically La Ninas have had a very variable effect in your region. And that goes up to Gawler and a bit further east of you as well. They don't quite have a stronger trend to being wetter that they do in some parts further west and further east of your location. What you can see, though, is in the years that we've had a negative IOD, which are that's these green ones and the dark blue, you can see there's the first one there. is that we've never ever had a year that's been drier, in the driest third of records, when you've had a negative IOD. I call this the West Coast Eagles effect. It's and it's pretty amazing that you can actually remove, a piece of the pie here just by having one particular climate driver. And we see this effect of the negative IOD also in pretty much the southwest quarter of Victoria, and then that sneaks over a bit into the southeast of South Australia, and obviously up to you as well. But when there's a negative IOD on, well, at least at the moment, with our history back to about 1887, there's never ever been a drier season when that has happened historically. It's really a strong climate driver predictor for some people in some areas. Rightio, different map here. Now looking back at climate at the moment. This is the top 150 meters of the ocean averaged out, and the blue colors are where it's colder than normal, and the orange colors are where it's warmer. The pink line is where it's exactly zero, exactly normal. So darker green is cooler and lighter green is warmer. The first thing to notice from our La Nina along the equator here under the surface is we've got a big slug of colder than normal water underneath here, which is upwelling at the surface and helping to maintain the cooler temperatures of the La Nina. We can also see there's a lot of colder water along the American, both North and South American coasts to depth quite a bit. The other thing we can see is just the absolute massive amount of incredibly warm water that's built up over here on the Western Pacific. And these amounts of warm ocean and cold ocean do not go anywhere quickly. The Pacific Ocean is not fast moving. It's a slow moving beast. The Indian Ocean's much quicker moving. You can get one of these phenomena occurring at the right kind of season in winter and spring. In about a month, the right things can happen to flip that over. But El Niños and La Niñas take months to develop. They hang around for months normally, and they take many months to decay. What is interesting is this massive amount of warmth over here is being built up over the last sort of 3 years. It desperately wants to get kind of back to the international date line where its home normally is. And we'll see soon. It's been the trade winds that have been blowing strongly for the past 3 years from east to west that have been pushing that warm water at the surface over to the north of Australia and holding it there. So that's why that really warm water is there in the Coral Sea. It's been pushed there by the trade winds. It's being held there. And as soon as the trade winds disappear, which they look like they're doing at the moment, this sort of system will slowly once again break down. But the thing we have is that this really big slug of warm water here is really prone to being pushed under the ocean by some westerly wind and getting it sent underneath back over to South America and potentially popping, well, at one thing, potentially neutralizing it. But if enough of it got over there, you could potentially see the kickoff of an El Nino type event, just because of the disparity here between, a really polarized, cold, warm side of the ocean. And this is just really prone to being pushed to the other side if we get some westerly wind bursts sometime. This is something we might, if we were to see it, would be happening perhaps in autumn next year. The Indian Ocean, nothing much to see there. There'll be no phenomena that happen over summer in the Indian Ocean. The Indian Ocean dipole, as I said, once it hits November, it's a May to November thing. That's when you're likely to see it, and not in the months out of it. Let's look at cloud patterns here at the moment. This is satellite imagery collated over the last month, looking in the areas of brown where there's been a lack of cloud, and the areas in blue where there's been an abundance of cloud compared to normal. There's been a lack of cloud at the international date line. Remember, our cold water tongue comes out here. And so just to show that change in temperature in here has really been enough to completely kill off the amount of cloud that's evaporating on the ocean in that area. And what's been going on is that we've just got this abundance of cloud to the northwest of Australia, I suppose. And that's quite La Nina-like pattern in here. But up here, it's quite a negative IOD pattern. This is probably as good as the cloud has looked for this negative IOD event. It's kind of quite strongly hanging in there, negative IOD-like in terms of the cloud. And then there has been a bit more cloud sort of coming down into Australia as well. I said the trade winds were what was all about, and they kicked off this event 3 years ago. They sort of shut down each time over summer and autumn, and then they kind of faded away, and then they've rebuilt back up again and gone again. And La Nina is really just an accentuation of the normal pattern in the Pacific Ocean, where the trade winds blow from east to west. These arrows show the wind direction, and the colours show where the wind is blowing stronger compared to normal. And so in the last 3 years, for almost 6 months of the year, the trade winds have really been blowing from the centre of the Pacific right over to Papua New Guinea, much stronger than normal, and pushing that warmer water over here and holding it there and not letting it get back, such that the height of the ocean is probably 60 centimetres higher here than what it is back here. So as soon as the trade winds stop blowing, gravity is going to say that this water here is going to want to move back into the central Pacific. And I would suspect, start to see that happening sometime soon. So we've got some stronger trade winds here, but let me tell you, compared to what they were 3 or 4 months ago, these are just a token gesture of strong trade winds. They were really that blue colour there over almost the whole half of the western half of the Pacific Ocean. I did say the negative IOD over here in the Indian Ocean, in terms of the atmosphere, was the cloud was showing very strong negative IOD signs, and the westerly trade winds blowing in here stronger into Sumatra is also a negative IOD sign. So it's interesting that the ocean down here, out here, is completely fallen apart, but the atmosphere above is still negative IOD-like. And the ocean's pretty weak out here in terms of the La Nina, but the atmosphere in terms of the cloud and the trade winds is still La Nina-like as well. But we'll soon see that the pressure patterns are nothing like that. And here are the pressure patterns. This is the last 30 days of pressure patterns. We look to link up the high pressure centres here at this time or any time of the year and look where the centre of that is. That's centred about Adelaide at the moment. And that Adelaide would be a normal springtime position for the latitude of the high pressure cells. At the top of the Great Australian Bight is a winter position, and around Melbourne is a summer position. And this is what gives the seasonality of our climate, dominated by high pressure in summer, and that lifts up in winter and allows the fronts and things through. So at the moment, our system is a little bit, we're almost into summer, and we're just in a classic spring position at the moment. Now, we would expect and hope, well, that is going to start moving south, and we're going to start seeing some more summertime activity. The other obvious thing that you can see is the big high pressure off WA, another high pressure off New Zealand, and we are in no man's land here. Unbelievably, we are not being dominated by high pressure, which we normally always are. But for the last 3 months, we have not been dominated by high pressure at all. In fact, high pressure has almost been nowhere to be seen. And that has just made it incredibly easy to drag moisture down from the tropics, because you've really got a trough line between these two high pressures that's allowing moisture transport down to the eastern half of Australia. If we look at the anomaly of pressure here, where the purples are lower than normal and the reds are higher, we can see that the pressure in between those two big high pressures, which have been much higher than normal, that means they move slowly, means they're blocking everything either side of them. But between them, we've had incredibly lower than normal pressure, which has meant we've had cut-off lows spinning up in the Bight and drifting across. We've had plenty of fronts sweeping up and just getting a connection up to the tropics at the drop of a hat. I've circled Darwin and Tahiti because that's where we measure the Southern Oscillation Index. And the pressure at Darwin has just gone closer to normal. It's been incredibly low to the north of Australia for almost 5 or more months now, first time since August. And that low pressure up here has been like pushing water downhill, coming down to us. But we can see now that Tahiti's normalised, Darwin's normalised, the SOI is currently plus 3.9, and the threshold for a La Nina is about plus 0.8 in terms of the plus 8, sorry, in terms of the pressure patterns. So what this shows us, and here is the SOI, we can see that in the last month, the pressure patterns around the equator have just completely collapsed back to normality. And so what we call now is this is an uncoupled system where you've got the ocean sort of vaguely still interested in La Nina, the undersea interested in La Nina, the trade winds kind of having a bit of a go, the cloud patterns still being like La Nina, but the overarching pressure patterns to the north of us have just completely collapsed, which makes it harder to get that moisture down to us now. When the pressure was really low, like it was up here, around Darwin, you know, any sniff of some sort of trigger mechanism to pull rainfall from the north could do that. And now that's looking like that's more difficult. And the other thing is that the negative IOD is really good at spinning up those cutoff lows as well. And now that it's kind of collapsed, it's probably see a lot less of those, fortunately, too, going forward in the next few months. So what I wanted to show here, before we move into predictions for now and next year, is really how or why climate forecasting is particularly difficult at some times of the year. So we've got a couple of locations here, the York Mid and Upper North and the southeast of South Australia. And what we've ticked in the box is the month of the year where any of these particular climate drivers have had a statistical correlation of either increasing or decreasing the rainfall. So I've got ENSO, which is El Nino and La Nina, the Indian Ocean Dipole, the Southern Annular Mode, the measure of frontal system activity spinning around Antarctica, the position and strength of that subtropical ridge of high pressure, both in terms of its latitude and how strong it is, and a phenomenon called the Madden-Julian Oscillation, which is a 40-day cloud wave that goes along around the equator and is a potential moisture source when it's sort of to the north of Australia. And if this was a live interactive audience, I would normally ask them now, well, what do you notice about that map? I'll give you a few seconds to think about that. What do you notice about that chart? And the obvious thing, of course, is that in March and April, there has never, ever been, well, sorry, wrong way. There are no strong correlations between climate drivers and rainfall, to be honest, in many parts of Eastern Australia at that time of the year. And to be honest, summer is not particularly good either. And that, unfortunately, is our lot in life. Climate drivers are usually active during winter and spring. That's when they're going on in the Southern Hemisphere. That's when they have their effect. And so this is where we should be looking for the information from climate models about, well, what are they saying for this year? And this is the frustrating thing. This is our lot in life, because this is the time of the year we'd really like accurate information in March or April. What is the season going to be like? At a time of the year when, to be honest, the ocean is always in reset mode in autumn. The Pacific and the Indian Ocean, but particularly the Pacific Ocean, resets itself in autumn from what it was in the spring and summer of the previous year, gets to autumn, goes to neutral, and anything can happen. And particularly it's to do with what happens to those trade winds up there off the Solomon Islands. It's really what's up to them in terms of, do they push a bit of water one way or do they push it the other way? So climate models have got their most skill at predicting things when there's an active climate driver actually in activity. And so we had a couple of climate drivers this year in activity, and they were predicted pretty well to occur. They eventually formed. And then they had quite strong responses in terms of what the models were saying, and they have in fact turned out to be true. The models have had a real purple patch this year. Let's not talk about last year for South Australia, where they pretty much predicted similar things, and those things basically didn't happen or happened quite late. So here's my forecast for December, January, February. It's not my forecast. It's the forecast of 12 models from around the world. Some coupled models, so big, massive supercomputers, some collections of big supercomputer models, and just one simple statistical model here. Model skill is moderate at this time of the year, but it starts to slip into a bit of low in parts of South Australia, so not that good at all, because we're coming into summer now, we're out of spring. The predictions for the Nino 3.4, the Pacific Ocean, we've still got 4 models predicting this La Nina to keep limping along, but you can see that a number of models are predicting it to have collapsed in the next 1 or 2 months. So we can see that with the pressure patterns dying off like they have, the event is trying to collapse. It's going to be interesting to see just how quickly, though, the trade winds, the pressure, that response starts to muck the ocean away and get it to go back to more normal temperatures. The prediction of the Indian Ocean, completely normal. Now, in terms of the summer rainfall here, we've got 5 models there predicting that things are likely to be wetter in your area. And depending on how close you are to the southeastern part of South Australia, you could add another 8 there. So if you're in the southeast, there's 7 of the 12 models. It's pretty much a pretty good consensus there that things look wetter there, and they continue wetter into Victoria. Our signal for wetter lasts longer than yours. We will see a drying trend happen in your state first as it comes across, and we see the final end of this kind of wet period. And just because some of these are the southeast, if there's moisture predicted for the southeast, well, it wouldn't be a big stretch to sort of suggest that it could get up near you occasionally as well too. So the whole problem we have is that ocean is really warm in the Coral Sea, and that ain't going away tomorrow. It's not going away in a couple of months' time, probably. So it really comes down to, can we get rainfall triggers to drag that moisture down? And if the rainfall triggers go away, as you would expect in summer, then we should be better off in terms of a lack of rainfall. Temperature, well, mixed all over the shop. These neutral forecasts here are not a forecast for average temperature. They're a forecast for anything could happen. So we've got 6 models like that, a couple warmer, 1 cooler, 2 cooler for your area, 2 warmer, and the rest sitting on the fence. So your guess is as good as mine, what might happen with temperature there. Certainly the predictions of cooler temperature in the previous 2 months have been really strong, but the models think at the moment that that's not likely to continue on. The real crystal ball gazing out to autumn of next year, where, as I said, the climate models would normally be struggling anyway, and there's no climate drivers in activity. We can see there's just one model, the Chinese, bless their souls, have got a El Nino coming in there. But I hope I've shown how that is not absolute pie in the sky. That is actually a plausible outcome if we see westerly wind bursts around around Solomon Islands, pushing some of that warmer water back underneath the Pacific and having it come up warm. You can see there's a couple of models starting to sniff a little bit warmer in the wind. I would say that there are more than just this Chinese model that are predicting an El Nino sometime in next year. There's actually a few models, and we'll see soon perhaps why that might be the case. In terms of autumn rainfall, just about all the models sitting on the fence there, as would be normal at the time of the year. I think there's just one there with a slightly drier prediction. And we start now getting a split between neutral and warmer temperatures for that time. Now I just want to very quickly talk about some new products from the Bureau of Meteorology from their Access Climate Model. Look, this has been exciting times over the last 3 years. I've been involved with the Forewarn Forearmed project, and Peter Heyman in South Australia has as well. Working with the Bureau and getting, the best information that I'd say anyone in the world is getting out of their Bureau of Meteorology's climate model. Once upon a time, we probably had the worst. We had the plus or minus median forecast, and that was our lot in life. Well, we've got just about everything you'd possibly want now. But these forecasts in particular are these climogram sort of forecasts. So I've typed, this is actually a forecast for the Barossa from the Bureau's climate model for the next 5 months, where you can see that November has probably been wettest on record. And then this is the forecast. You've still got that December forecast there coming out slightly wetter, and then it's sort of going back to normality and even sniffing sort of decile. The yellow there's decile 3, 4. So, slightly drier potentially as we get in there into the new year in January, February, and March. This is fantastic. These are box and whisker plots, if you don't know, and you know the spread of this shows how wide a spread in the model there is. But what you can see is there's not a lot of spread in the dry end of the forecasts, but there's a lot of spread in the wet end of the forecasts. And that's because of that warm ocean up there. That's what's driving the uncertainty in, you know, some of these things are some of these model runs are staying wet, but the majority are not. They're coming back to normality, which, as I said, which is as we would expect at some time with this event eventually breaking down. If we look at maximum and minimum temperatures, well, of course, the maximums have been quite cold, as you would well be aware. December's still predicted to be a little bit cooler, but then pretty rapidly, once we hit the new year, we then go into warmer. And the minimum temperatures, which had been sort of skipping between warmer and cooler, are predicted to go warmer once we get to sort of December, January, February, March. So people with grapes, that might... well, it might make more sense to you, I suppose, if you're actually growing something over the summer time. To get these maps, it's pretty easy. You just go to the Bureau's climate webpage and you just click on the old boring plus or minus median forecast. And if you click anywhere on that map, you can get these charts and a couple of other different types of ones as well for the forecasts going ahead. And yeah, as I said, really excited about them. So let's look at triple La Niñas and what's happened in the years after. I think this is my last slide here, Jane. So we've had 3 La Niñas a row, and we had that in 1954, 55 and 56, 73, 74 and 75, and 98, 99, 2000. And in 1957, it was an El Nino positive IOD at the drier end of things, 287 mils of growing season rainfall at Tanunda this time. That was a decile 2. And then 1958, it flipped to negative IOD and went wet. In 76, it was a neutral year, but it was decile 1. It was not real chop at all. And in 1977, it came back with a proper El Nino, and that was decile 1 as well. And then in 2001, it was neutral. It was wetter at 495. Then we had an El Nino in 2002, which you might remember, and that was decile 2. And to be honest, it's often really just those decile 1 years that really tell you up more than anything. So even statistically, there's an El Nino probably coming somewhere between either the next year or the year after that, just from history we see here from triple La Niñas. Some of you are probably thinking, is there any evidence that we've ever seen 4 La Niñas in a row? And at least not in the instrumental and even the poor shipping's log record back to sort of, you know, the 1880s. We've only ever seen 3 in a row. And I think just, you know, having 1 La Niña really increases the chance of getting 2. Getting 3 is quite rare. Getting 4, well, we'd probably say that is close to unprecedented. Eventually, the physics of the ocean are going to want to return back to normal at some stage. So possibly after 3, they try and do that. But as is often the case, after it's been in one direction quite extreme, it sometimes flips pretty quickly back the other way. So we often see El Ninos very rapidly follow La Niñas, and sometimes we see El Ninos follow, sorry, La Niñas following El Ninos, and sometimes we get El Ninos following La Niñas. So just in summary, the Pacific Ocean is a pretty weak La Niña at the moment. The atmosphere has been really strongly La Niña. Some elements of that remain, but it is showing signs of weakening. Particularly the pressure now at Darwin is really quite normal, and that's going to make it harder to bring that large amounts of moisture down. The IOD, it's decayed as we would expect at this time of the year. We will not see that until as early as May next year if it's going to do anything at all. But the atmosphere above it still seems a little bit interested. Rainfall predictions are split between neutral and wetter for summer, and plan for anything in terms of temperature over the summer period. So that's it from me, Jane. I bring to your attention, if you don't already get it, our newsletter, which you can subscribe to by sending some contacts to these things down here, our YouTube clip, and going to our podcast channel, My Rain Gauge is Busted, if you want to listen to myself and my colleagues and some very learned people from around Australia talk about climate and climate phenomena.
Thank you so much, Dale. That's absolutely fantastic. Now we've just got a few minutes for a Q&A session. If any of our audience participants have any questions at all, please feel free to raise your hand or type in the chat box. I think we've got you for another few minutes, don't we, Dale, hopefully?
Oh, I'm not going anywhere. So I've gone over time.
Fantastic.
So the other people at home are just sitting there eating their dinner, aren't they? So they're
possibly.
maybe.
That's right. That's it. So here we've got a first chat here. Is the Bureau of Meteorology the best forecasting website we can use, Dale?
Well, that's thank you to G, whoever that is. That's
Georgie.
It's a Georgie.
Georgie
That's a great question. It's look, in terms of the forecasting for Australia, it's certainly up there. It's not a dog by any stretch of the imagination. And it keeps improving. It keeps getting better at each iteration of that model. That's the access model. The good thing about these things here is that I show these are over months, but what you may not be aware is that you can actually go out to weeks. You can actually get a 4-week forecast out in weekly time slots from the model, from the climate model, not the weather model. And that's really interesting for looking at, when you're doing hay and doing urea and things like that, where the weather forecast is one thing, but gee, it'd be good to know what's just on the other side. And the problem is with the best weather forecasts in the world, at day 8, most of them are no better than flipping coins. And there's no shortage of them that go out 2 weeks, but after day 8, they're not worth a lot. And so the climate model that the Bureau's got is looking at their climate model going out the weeks after the weather forecast. So I'd recommend having a look at that too, because that tells you some information that no other climate models in the world are currently providing. This model is really, and the Bureau is really breaking new ground, I suppose, in really giving, almost there's almost nothing left that model could show you that isn't actually kind of being shown in terms of rainfall and temperature at the moment. Is it likely to get? But well, that's a good question. I'll tell you what. Let's put that to the test. I'm going to bring this over to here. I'll show you how easy it is. Hopefully, we're screen sharing that Zoom site now, are we?
Yes.
We are. Yeah.
Yep.
Cool. Right. So we're going to go to the Bureau's website. Here we go. Let's just go to the home page. So go to the Bureau site. You get that? You can see that one, Jane?
Yes, I
cool.
can.
Rightio. So to get to the climate section, you either go to climate and past weather, or you can go down here and hit the climate bit. Either of those 2 buttons take you to the same spot. And then you've got the long range forecast here, the famous map we love, which is the chance of above median forecast. Now, the question was about hay. What's happened to that? It's gone. Come on. Yeah, that's pretty funny, isn't it? There he is back then.
Right, there he is.
Now, so you can point to anywhere on this thing, or you can just type in up here and type Barossa. That will come up. There we go. Up it comes, dooley. Right, so this shows a different map now, a graph. This is the one I showed you before. Here is this is here. This one here is what we call the decile bar chart. And so from the 99 model runs in the last 3 days of the model, this is where they've fallen out in terms of the decile ranges for rainfall. And you can see, and this is just for the 4th to the 10th of December, a 1-week slot. And if you got over 11.5 mils, that'd be decile 9 and 10. If you got less than 1, that'd be decile 1 to 4. But you can see that forecast there is really predicting normal rainfall, which is somewhere between 1 and 4. It's not really skewing to the dry or the wet. If we go to the next week, which is 11 to 17, it's thinking about it. Here we go. Well, we can see that one is, unfortunately, it's splaying towards the wetter end. Now, it's only 10 mil, but there's been a lot of times these ones have been up around 35% chances of decile 9 and 10 for some of the weeks we've had. And that's been giving us crazy rainfall sometimes. But that's kind of an example of a forecast that's tending wetter. And I think that's the problem, is that we're not over this kind of wet event at the moment, unfortunately. It's petering, but when you've been used to getting a heap of rainfall every week, it just isn't something that's just going to stop like that, unfortunately, which is, I know, very frustrating for people. And even if we looked out to I'll tell you what we might do is, what's going on here. We might have a look at the weekly. We'll have a look at this one. So that, so this is the week forecast. So it's going, slightly drier to normal here. And then it's got a slightly wetter, back to normal. So there's kind of a couple of, that's a slightly wetter one. This one's a bit more normal. That's the one we're looking at. That's the second one. This is the third one here, which sort of drops back drier. But you can see that the spread in that starts getting huge. In terms of the model's got no idea, but it could be wet, but it may not be. You can do this for temperature as well. So if we go to temperature, let's look at maximums. We'll see what curing sort of weather we've got. You can do this with the decile bars as well as with this. So there's our decile bars for temperature. Well, it doesn't look too bad, but 27 degrees, you'd certainly be drying hay at that. But if we click at this one here, we can see a bit warmer, get it away, do we have a chance? And then sort of more normal. Yeah, so a peak of warmth between the 4th and the 11th, and then it kind of goes a bit more normal-ish, which, iffy-ish kind of rain. It doesn't look like there's a massive gusher coming, but, this time of the year, 5 and 10 mils is as useless and annoying as anything when you're trying to get hay in the bale. But I think I've been telling people in Victoria a long time, if up for this year, that you've never made silage, this year could be the year to have a go, because haymaking has just been incredibly problematic over this way, and I imagine it's been pretty problematic over your way.
I believe it has been, Dale. Absolutely. bit of a juggle with the weather. Definitely. And also fly strike as well is a problem at the moment.
Yes, so. Absolutely. And mozzie bites on the humans.
Oh yes, we can do without those. Definitely.
Horrific.
Definitely. Well, look, Dale, thank you so much. I'm not sure. I don't think we've got any more questions from our participants at this stage. Has anyone got any more questions I'd like to ask Dale before we thank him very much for his wonderful presentation?
You can speak up now if ever hold your peace.
That's it. I
just
think
send us an email if you're too scared. Just that'd be a problem.
That's fantastic. And at this stage, you think there's a chance we could have an El Nino weather event next year or the year after, but we won't know until closer to the time.
I think that's just a statistical increase in the chance because of that triple La Nina effect, that it goes that way, and a fact that there's a few models leaning towards El Nino. There's no model leaning towards another La Nina coming.
Okay. Well, that's really good to know. That's very helpful moving forward. Yeah, wonderful. All right. Well, Dale, thank you so much for your fabulous presentation and for your time and your expertise tonight. I'm sure that's been greatly welcomed by our audience and definitely appreciated. To our participants, the BIGG group will be sending a QR participant questionnaire on your email addresses. If you could kindly have a look at that, that would be wonderful. And there will also be a recording on our BIGG website for those that have missed Dale's presentation tonight. And Dale, I'd like to thank you very much once again for your wonderful presentation, for your referencing and your referrals to all of our resources we've got here, which was awesome. And we'll look forward to listening to your podcast and following your recommendations for climate information.
No worries. Thanks, Jane. All the best, everybody.
Thank you very much.
Thanks to Georgie, who ran the back end of the Zoom as well. It doesn't work without that either.
Absolutely. All right.
All the best, people. I hope we get crop in the bin and hay in the stack. That would be a marvelous thing.
That will be awesome. Let's hope so. Thank you very much, Dale. Good night.
Good
Thank
night.
you.
Catch up.